Hello students, good morning. So in this video, let us discuss about Oersted experiment and magnetic field of electromagnetism chapter. So before going for Oersted experiment, let us discuss about some fundamental things. The first one is about bar magnet. So bar magnet is a rectangular piece of object made up of iron or steel or other ferromagnetic substances having permanent magnetic properties. Right? Now this is the bar magnet. In the diagram you see this red color. This we call it as bar magnet. So this is made up of ferromagnetic material. What is this ferromagnetic material? What are these magnetic materials? Magnetic materials means that substances which produce magnetism. So three types of magnetic materials will be there: dia, para and ferro. So diamagnetic substances are having a very feeble means very low or weak magnetic properties compared to para and ferromagnetic substances. Example, water is the example for diamagnetic substance. Next, paramagnetic substances. So paramagnetic substances, they have magnetic field more than that of the diamagnetic substances and less compared to the ferromagnetic substances. Their magnetism property is more compared to diamagnetic. Okay. Now next, ferromagnetic. These are very strong magnets. Right? These have a very strong magnetic properties. Examples: iron, steel, cobalt, nickel, etc. are ferromagnetic materials. Right? So magnetic materials means which produces magnetic field, that we call it as magnetic materials. So bar magnet is made up of such a ferromagnetic material. Now it has two poles, north and south poles. Now if this bar magnet is suspended by tying a thread at any place on the earth, we find that it aligns itself with its north pole facing magnetic north pole of earth. Its north pole facing magnetic north pole of earth. Then why I used the word magnetic north pole of earth? Why means earth itself is a huge magnet with north and south poles. Earth itself is a huge magnet with north and south poles. We call it as geographical north, geographical south poles. Alright? So when we suspend this bar magnet freely in the air, it aligns itself, means it comes in the direction, its north comes in the direction of north of earth. Okay. Now next, what is compass needle? So this is specially devised to detect the magnetism or magnetic field. If magnetic field is present in that particular region or space, it deflects. If not, it will be in a rest position. So by its deflection, we can understand magnetic properties or magnetic field is present there. Now does compass needle get deflected by bar magnet? Yes. Why means bar magnet produces magnetic field. So when we bring bar magnet nearer to the compass needle, 100% compass needle will deflect due to the magnetism produced by the bar magnet. Now let us come to the Oersted experiment. So first let us see The materials required for the Oersted experiment: thermocol sheet, 2 thin wooden sticks of height 1 centimeter with small slits at the top of their ends, 3 or 9 volt battery, copper wire, magnetic compass needle, bar magnet. Right? Now let us go for the experiment. What this Oersted had did. What he did, he took a thermocol sheet. This is thermocol sheet. He took 2 wooden sticks with slits at their top. Okay, wooden sticks with slits at the top. Now next, he took a 9 volt or 3 volt battery, and with that, now this is the wire, straight wire. Okay, here in diagram you see straight wire, right? Now this is key. Okay, the symbol of key. In such a way we will give the symbol of key. Okay, key. Next, battery. With the help of copper wire, batteries, the 2 batteries, in such a way he connected. Alright? Okay, again I will show. Now this is the wire, wooden sticks with slit. In that slit only we adjusted this wire. Key, 3 or 9 volt battery, and these are copper wires. Okay, a closed circuit. Now first, don't on battery, keep battery in off position. Now this is compass needle, this one, the circle which I drawed, compass needle. Okay, the circle which I drawed, compass needle. He kept compass needle below the wire. See the diagram. He kept compass needle below the wire. Now he brought bar magnet towards this compass needle. First step, what he did, he brought bar magnet towards this compass needle. Now say what happens? Compass needle will deflect if magnetism is present. Bar magnet produces magnetic field. So when bar magnet comes closer to the compass needle, what happens? Compass needle deflects, indicating the presence of magnetic field nearby it. Right? Now you remove the bar magnet. Okay, now let us remove the bar magnet. Second thing what he did means, the completely you place bar magnet away from this circuit arrangement. Now on the battery. Now on the battery. Same, the compass needle is below the wire. On the battery. When you on the battery, current flows in this wire. Okay, here the wire is there, no? I current flows through this wire. And we observe that compass needle is deflected. Okay, we observe that compass needle is deflected. Now the question is, bar magnet is not here. Not only the bar magnet, but there are no any other source nearby the compass needle which produces magnetic field. When magnetic sources are not nearby the compass needle, actually it must not deflect. But it is deflecting, showing the presence of magnetic field nearby it. Then from where this magnetic field is produced? Right? There are no sources which produce magnetic field. But also the needle is deflected, indicating the presence of magnetic field. So it clearly shows that the current passing through the wire produces magnetic field. The current flowing through the wire, conducting wire, produces magnetic field. So only compass needle has deflected. Right? So from this, Oersted proved that the flow of current produces magnetic field. Okay? The flow of current produces magnetic field. Now next let us go for some questions. Okay? So why magnetic needle deflects? As usual, now only I said no, because of presence of magnetic field. The electric current flowing through the wire produces magnetic field around the wire. This magnetic field interacts with the Earth's magnetic field, causing compass needle to deflect. Okay, this causing compass needle to deflect. What happens in the absence of current? When current is absent, no magnetic field. Needle does not deflect. So compass needle aligns with Earth's magnetic field pointing towards magnetic north. Right? Now next, what happens when compass needle is kept above and below the wire? Above wire, current flows from south to north. We will experience magnetic field that circles the wire in anti-clockwise or counter direction. Okay, in an anti-clockwise direction. Now, if this is the wire, in such a way, the magnetic field circles the wire, means in such a way. This circles magnetic field lines, circles the wire. Okay, how? In a counterclockwise or anti-clockwise, arrows I am keeping. Okay, in anti-clockwise direction. Right? If it is below, it also circles the wire, but in a clockwise direction. So this is clockwise direction, this is anti-clockwise direction. Alright? Now when it is placed above the wire, the magnetic field lines are directed upwards towards the north. When it is placed below the wire, right, compass needle placed below the wire, the magnetic fields are directed downwards towards the south. Right? Next, what we understand by Oersted's experiment? Nothing but electric current produces magnetic field, and we calculate that magnetic field depending upon the nature of its strength and direction. In next topic, let us discuss about this. The change in direction of compass as it moves from below the wire to above is due to orientation of magnetic field lines created by the current. The compass needle with local magnetic field changes depending upon needle is above or below the wire. Now this change is direct result of right hand rule and nature of magnetic field around the current carrying wire. Right hand rule in above topics, let us discuss about that. Next, magnetic field. Okay, field. Every time we will not use the word field. We use the word field only when one object experiences the force by other object without physical contact. You will see the experiments, no? You will take the magnet, you will keep some iron pieces. Even though both are not in contact, these iron pieces, the magnet attracts the iron pieces. Okay, means the magnet is exerting the force on iron pieces and attracting it. So when there is no physical contact only, If the force is applied by one object on other object, then we call that area or space as field. Okay, or I can say that the area or space where magnetic effect is present is called magnetic field. Magnetic effect I am saying, so magnetic field. If I say electric, then electric field. Right? Now some questions. How this field is produced? By moving electric charges. Now only Oersted experiment we explained, Can we observe field of bar magnet? Yes. Two methods are there. One, you just sprinkle iron fillings. Now in diagram I showed, we sprinkled iron fillings on the bar magnet. Automatically it takes this shape. So now see how the shape of magnetic field lines are there. So more explanation in next video I will say about this magnetic field lines. Now just see, these are the field lines. Now next, another activity to draw the field lines. How to draw the field lines? Here you see the first diagram. We took a white paper, placed it on the horizontal table. We took a bar magnet, right? In between this paper we placed bar magnet as shown in the diagram. Okay. Now we took a compass needle. First diagram you see. Compass needle, and then by taking a pencil, we will place compass needle at one point near the magnet. Okay. And draw the dots on either side of compass needle. Then move it. Again do the dots. In such a way you see the second diagram. Again we will bring that compass box to the other end. Okay. In such a way, by keeping the dots we will bring to the other end. After that you just go on joining the points. So you see the structure. If we join the points, this line segment, you will get this structure. Again change the position of compass needle. See the diagram 2. Again let us keep the dots from north to south. In such a way on either sides we will repeat the experiment. Okay. Now on either sides if we repeat the experiment, now we will get, see the second diagram, we will get such pattern. This is nothing but magnetic fields, the pattern of magnetic fields. Right? So now when we place this compass needle near the magnet, it deflects. And when you have to keep the point, immediately you must not keep the point. So how the needle will be means, now in such a way. This is, if this circle is a compass box, needle will be in such a way. Here arrowhead will be there for the needle. Okay. This arrowhead indicates the direction. So first it deflects. We have to wait until the needle comes to the rest position. After it comes to the rest position, coming to the rest position means aligning in one particular direction. After coming to the rest position, you have to make the dot. Again move the compass needle. Again it will deflect. After coming to the rest position, again you keep the dot. In such a way, we will go on keeping the dots on either side of bar magnet. Okay. Now compass needle is deflecting means showing the presence of a magnetic field. Next what I said, this arrowhead settles in one particular direction, which clearly shows that magnetic field is having direction. Arrowhead settles in one particular direction, I said. Comes to the rest position in one particular direction, then only we have to keep the dot, which indicates magnetic field will have direction. Now repeat the experiment, you will get such a magnetic field. And see this pattern, no? The first two curves you see very closer to each other. The third curve, there is a distance between the second and third curve. Do you know what it indicates? It indicates the strength of magnetic field. Means as you go away from the bar magnet, the strength of magnetic field is decreasing. Again we will discuss in the next topic, magnetic flux, of my next video. Here just generally I am saying. Now when we come closer to the bar magnet, magnetic field will be more. So strength of magnetic field is more nearer the bar magnet. As we go away from the bar magnet, the strength decreases. So we can say that the strength varies from point to point on this sheet which we took. Right? Not only sheet, in the region where magnetic field is present. Now the next question. Now take the now in this experiment we kept the compass needle beside the magnetic field, bar magnet. Now let us place the compass needle above the bar magnet. Again surprisingly you will find the above the bar magnet you will place also needle deflects. It clearly shows that magnetic field is three-dimensional. Either beside or above or bottom, wherever you keep the magnetic needle around this bar magnet, you will see needle deflects, indicating that magnetic field is three-dimensional. Next, let us go for some questions. What do you understand by this activity? Magnetic field exists in a region surrounding the bar magnet and is characterized by what I said, strength and direction. Characterized by strength as well as direction. Is there any change in direction of needle of magnetic compass? Why? Yes. The needle of magnetic compass is affected by bar magnet without any physical contact itself only. Now last curve you see, any physical contact between the compass needle and bar magnet? No, but also the needle deflects. Without any physical contact only, it is deflecting. A force causes the needle to deflect, and what that force we call? Nothing but we call that force as magnetic force produced by the magnetic field of bar magnet. Next, why the orientation of needle is different at different places? Because it has direction and direction changes from one place to other place. Is magnetic field three-dimensional? Yes. Wherever you keep the compass needle, either above or beside, you will find the deflection in the needle, indicating that it is three-dimensional. Can we define magnetic field? Yes, we can define. How? The particular region or space surrounded by the magnetic effect, we call it as magnetic field. So in a particular region or space up to where the magnetic effect is present, up to there we call that field as magnetic field. So this is all about the Oersted experiment and magnetic lines. In my next video, let us discuss about lines of field, magnetic flux and magnetic field due to straight current carrying conductor. If you like this video, like it, share it, subscribe it. Stay with my channel to receive the complete topics of electromagnetism class 10. Thank you.